What's up, future CPAs? Welcome to the explainer that is literally going to be your best friend for the Management Advisory Services part of the LCPA. Look, if you're a BS accountancy student right now, I know exactly what you're dealing with. You're not just trying to cram formulas for a quiz tomorrow, right? You need to actually encode this stuff into your brain for, a solid 3-year attention span so you can absolutely crush those board exams. Well, that's exactly what we're doing today with linear programming. We're putting out all that textbook fluff and building the ultimate brain-friendly study guide.
All right, let's dive right into this. Here's our roadmap. We're hitting the LECPA blueprint, translating business, the DOC components, the strict non-negativity rule, the PAD assumptions, and capping it all off with some rapid review hacks.
First up, the LECPA blueprint. Like, what actually is linear programming?
So, notice the specific language experts use here. Linear programming, or LP, is basically a mathematical technique designed to help operations managers plan and make decisions relative to allocating limited resources. Because, let's be real, in the actual business world, and definitely on your exams, companies never just have unlimited time, unlimited cash, or infinite materials. LP is basically your ultimate tool for making the best possible choices when your back is against the wall with all these constraints.
Moving right along to our second part, translating business into math.
Your core objective here is to basically act as a business translator. Think about it. The real world, it's incredibly chaotic. Business owners are going to come to you with these messy, purely verbal problems. They'll be like, oh, we have way too many baristas on Tuesday, not nearly enough matcha powder on Thursday, and we really need to maximize our profit. They speak in words. Your job as an accountant is to take all that verbal chaos and translate it into a highly structured, solvable, formal mathematical model. That translation process, that is the absolute essence of LP formulation.
Okay, let's hit section 3, the DOC model components.
So the crucial point is, if you actually want to retain this for 3 years, you need some serious cognitive scaffolding. Every single linear programming problem, literally no matter how complex they make it look on the exam, is built sequentially using 3 steps, DOC. Step 1 is defining your decision variables. Step 2, formulating your objective function. And Step 3, setting your constraints. Let's quickly break these down one by one.
First up, the D, decision variables. These are the controllable inputs, or the actual choices available to a decision maker. Simply put, these are the exact quantities you need to figure out. For example, maybe it's the exact number of tote bags versus graphic tees a local startup needs to produce. On your scratch paper, these are your X and Y factors. They're literally the only things management actually has the power to tweak and control to change the final outcome.
Next is the O, the objective function. Every business has a goal, right? And in LP, this function mathematically represents that very goal. You're basically always looking at a tug of war between 2 directions. On one side, you want to maximize the good stuff, profit, revenue, yield. On the flip side, you want to minimize the bad stuff, costs, time, distance. So, pro tip, when you're reading a board exam question, immediately scan for words like maximize profit or minimize cost. That's just your objective function waving a giant red flag at you.
And finally, the C in DOC, constraints. I actually love this quote from our source material. Constraints limit the degree to which a manager can pursue an objective subject to limited resources. This is basically the harsh reality check of business math. Sure, you want to maximize your profit to 1,000,000 pesos, but guess what? You only have 240 hours of assembly time, or maybe just 100 meters of fabric. The constraints are what keep your mathematical model completely grounded in reality.
Which perfectly sets up section 4, the strict non-negativity rule. Think about this for a second. Force your brain to do the active recall here. Can a startup factory physically produce negative 50 cups of iced coffee? Obviously no way. The answer is no. You can produce 0 cups, or you can produce a positive number, but you cannot manifest negative physical objects into existence. This really simple logical fact forces all of our math to adapt.
And that, my friends, is exactly why we have non-negativity constraints. In formal mathematical terms, your decision variables literally cannot have negative values. They must always be greater than or equal to 0. Whether you're working with x1, x2, or x3, you have to explicitly state at the very end of your model that all variables are greater than or equal to 0. Honestly, if you forget to write this on a formulation problem, your model is technically completely invalid, because without it, the math might blindly suggest some highly profitable but physically impossible negative production run.
Moving to section 5, the PAD core assumptions.
And this brilliantly illustrates our second major study hack for the exam.
Behind every single model are these strict theoretical rules you just have to accept for the math to work properly. Think of a writing pad: proportionality, additivity, and divisibility. Let's unpack exactly what these mean so you can easily spot them on your tests.
First, proportionality basically means we assume perfectly straight lines and constant returns to scale. If 1 unit of a product takes 2 hours to make, LP strictly assumes that 5 units will take exactly 10 hours. There are no efficiency discounts, no learning curves, just straight math. Second, additivity means the total resource usage is literally just the sum of the individual uses. No weird overlaps, no synergies. If product A uses 3 hours and product B uses 2 hours, together they use exactly 5 hours. Simple, perfectly additive.
The final letter in PAD is divisibility. This is the assumption that your decision variables can take on literally any fractional value. Unless you are specifically doing what's called integer programming, which, trust me, is a whole different beast. Standard linear programming is perfectly happy telling you to produce 1.5 units, or maybe use 3.7 hours of labor. The math completely allows for decimals and fractions to find that absolute most precise optimal sweet spot.
All right, we are in the home stretch. Section 6, Rapid Reviews Study Hacks.
Let's pull this all together and see how this builds your confidence. When you're sitting there, staring down a massive, confusing paragraph of text on the board exam, I want you to just take a breath, visualize a blank slate, and remember DOC. D, define those decision variables. What are your X's and Y's? O, objective function. Are we maximizing profit or minimizing cost? And C, constraints. What are our harsh limits on time and materials? Oh, and absolutely never, ever forget your non-negativity constraint at the very end.
And when those tricky, theoretical, multiple-choice questions pop up asking about the underlying rules of the model, you just remember your PAD. Proportionality, additivity, and divisibility. These are the 3 core pillars that hold up the entire logic of linear programming. By organizing all this chaos into DOC and PAD, you are doing your brain a massive favor and really cementing this stuff into your long-term memory bank.
So, what does this all mean for you? Well, it leaves us with this final empowering question. Now that you have the DOC and PAD frameworks totally locked and loaded in your brain, how will you translate your next messy business problem into a perfect mathematical model? You've got the tools, you've got the structure, and you are officially ready to tackle these board exam questions like an absolute pro. Keep practicing those translations and go crush your studies.